I'm very happy to have our next speaker because actually we worked together this summer to organize a big workshop on SwiftUI for 30 iOS developers at Airbnb, which was quite, as you can imagine, a ride. So please welcome Donny Wals.
Good afternoon, everybody. Do we still have some energy for like a couple more talks? Yes? Good. All right, so my name is Donny. I don't have to talk too much about myself, I guess. I write stuff, I teach people stuff, like Craig mentioned. We did a workshop for Airbnb in the summer. Not on any of these two topics, but if you're interested in either learning Combine or Core Data, you can either Google the names of my books or just scan the QR codes or whatever, and you'll find them and you can learn more about that. But today I'm here for a completely different talk. It's about building custom SwiftUI property wrappers. And the reason I'm talking about this is because I've done a lot of SwiftUI work in the past year or so. And I've learned a lot about SwiftUI, and I've learned a lot about how it works and how we can make apps or write code that feels like it belongs in SwiftUI. So in this talk, what you'll learn, first and foremost, we're going to talk about what property wrappers are and how they work. I'm sure that most of us will have used a property wrapper in one way or the other, but do we actually know what they are, and do we know how we use them? Well, you know how to use them, but how they actually work on the inside and how they take whatever they wrap and manipulate that potentially. And of course, SwiftUI is special, as we all know. So a regular property wrapper obviously will not be good enough for SwiftUI. And we're going to talk about why that is and how we can make a good one. And here's really the interesting part, right? Because we're going to build a property wrapper that taps into SwiftUI's view environment and lifecycle, which means that we can make our property wrapper really part of what SwiftUI can do, which is amazing. And of course, here's the most important part that everybody always asks about. How do we test this thing in SwiftUI? Because SwiftUI views are obviously, or maybe not obviously if you've not tried it, but if you've tried it, they're notoriously hard to test. And this property wrapper will have similar issues, and we'll figure out how we can test it anyway. So if you've done SwiftUI, I'm sure code like this looks pretty familiar. It's super basic, and the interesting part here is this, right? The state property wrapper. So when we use this, what does it actually do? Well, first and foremost, it's a container that holds some mutable value, right? It allows us to mutate values or data that's held in a struct. Otherwise, we would not be able to do this, but with state, we can. And what's interesting is that whenever we mutate that value, the view will update. Right, so SwiftUI will redraw our view whenever we change our state. And what's also interesting is that whenever our view's initializer is called, that state is not reset. And that might make a lot of sense to you initially, but if you try and remember the code you just saw, we said var is active equals false, which means that whenever we initialize that view, that's going to be the default value. However, if we change it and we use state, somehow that new value is retained whenever that view gets reinitialized, which is pretty cool. And also you can obtain a binding to state property, which means that we can give it to another view and allow that other view to change the state that is owned by the source view. All pretty cool stuff. Another example of what you may have seen before is this code. It uses the fetch request property wrapper. If you're not familiar with this one, it allows us to fetch data based on a Core Data entity or fetch request. So you can say, hey, SwiftUI, go to Core Data and get me a list of posts or get me a list of users or whatever we have stored. What's also really cool is that this fetch request property wrapper will observe Core Data and tell SwiftUI whenever our fetch data has changed, which means that our view now updates whenever our data updates, which is fantastic. And here is a really interesting thing. It leverages the SwiftUI environment for its dependencies. Because if you're familiar with Core Data, you'll know that we can only fetch data from a managed object context. And the fetch request property wrapper can take a managed object context from the SwiftUI view environment. And SwiftUI comes with many, many, many property wrappers. Right? If you're working with SwiftUI, you'll be using them all over the place, not thinking about it too much. But if you do start thinking about it, and if you start thinking about what appears to be Apple's vision with SwiftUI, we can come to a few conclusions. One is that SwiftUI views are apparently completely okay to own or receive state directly. And this is something we're not used to in UIKit. Right? In UIKit, you want to have your state or your logic or your business logic or data sources all in view models or other objects. Whereas in SwiftUI, apparently, given that we have a state property wrapper and a fetch request property wrapper and things like app storage, scene storage, and whatnot, it's okay for views to own this state. We can also conclude that apparently we leverage property wrappers to obtain and hold data. And here's a very important one. We technically don't need extra layers to fetch data. Right? If we have our core data store, we can use a fetch request property wrapper to take stuff out of it. And apparently, according to Apple, that's completely okay. Whether or not you agree, let's set that aside because we're thinking about what Apple apparently is thinking. So given all of this, wouldn't it be cool if we could write code like this? Right? And if it doesn't stand out what I'm talking about here, look at this. Remote data endpoint feed that gets me a feed of posts. This is really cool, and it feels right at home in SwiftUI. Right? It looks exactly like the fetch request or state property wrappers. So let's go and build this. Let's see if we can do that. But before we do, let's quickly talk about property wrappers for just a minute. We can define property wrappers by writing the @property wrapper annotation on top of a class or struct. There's one requirement for a property wrapper, and that is that it has a wrapped value. Right? So that means that this property wrapper string sample is going to wrap some value that is a string. It can't wrap anything else. A lot of property wrappers will use generics, but ours doesn't in this case. And we have a projected value. This is a value that we can provide whenever somebody accesses our property wrapper using a $ prefix, which is exactly how binding works. Right? A binding is a projected value for state in SwiftUI. So if you look at how this would be used, it could look a little bit like this. Right? We have our string sample property wrapper that we apply to the string hello world, so that becomes the wrapped value. And we have 3 ways to access this property wrapper. We can access example with no prefix. That will get us the wrapped value of the property wrapper. We can use the underscore prefix. That will get us an instance of the property wrapper itself, in this case, string sample. And lastly, we can use the $ prefix to get the projected value. In this case, that would be another string, projected hello world, but it could also be an integer that represents the count of my string or anything else. Before we continue, just a quick reminder, this is our goal, right? A property wrapper that we give an endpoint to get a feed of posts. So let's start with the basics of what we just seen. We just define our property wrapper, class remote data. It has an endpoint that we're going to fetch data from. And the wrapped value here, I've hard-coded that to be posts. Of course, in a real property wrapper, this would be generic, but to keep things a little bit simpler, because we all still have not digested Antoine's talk, we're going to hard-code this. Also, it's like almost 6, so we're not going to do generics. Okay, so this is the basics, but obviously this doesn't fetch data yet. So we're going to add a simple data fetch function. And if everybody's paying attention, can we all read this? Sort of, you're doubting me right now. Can we do that? Thank you, yes. Because I told you this one to be testable, and if we're using this, obviously this cannot be tested. This is very, very bad. And we'll get to that. All right, but first I want to sort of talk about that function, and then we're going to improve this as we go. So we have the fetch data, and we update the wrapped value with data that we fetched. Right? So our wrapped value for the property wrapper initially will be an empty array that's going to hold posts. We fetch data, and then we decode our fetch data into posts, and we make that a wrapped value. So now we have a list of posts. In this code snippet, I have a function called URL4, and I showed you that endpoint object, and I just quickly want to show you this because they're really not interesting at all. Right? This is literally how I coded them in the sample, so if you were worrying about what does those things do, stop worrying now, they're not interesting at all. Okay, so about this, right? Because this is really what the whole talk is about. Where do we grab our networking layer from? Because if you remember what we're trying to build, we have this add remote data, give it an endpoint, and we magically get a list of posts. So we're not doing dependency injection there. We're not going to be able to say, oh, this is the networking layer to use. So we need to get it somehow. And if we think back to what fetch request does, it takes the managed object context from the SwiftUI view environment. So how about we grab our networking layer from the SwiftUI environment? And if you've ever tried to do something with SwiftUI, you'll know that, well, the environment is only available to SwiftUI views. We can't just randomly grab the environment. We have to be part of the hierarchy of SwiftUI to be able to do that. We have a tool for that, dynamic property. Dynamic property is a protocol with only one requirement, that is that we implement an update function. And SwiftUI will call that function whenever we need to update our fetched data, or whenever we need to update our underlying data. What's really cool is that we have something that conforms to dynamic property that exists within a SwiftUI view. It makes environment values available to our property wrapper, which means that with dynamic property, we can now take whatever we want out of the SwiftUI environment. There's one important remark. We should not internally store state. And I'll get to that later, but just planting that seed in your head right now. What's also really cool is that dynamic property can hold observable objects and even things like state to tell SwiftUI that something changed. It essentially becomes a SwiftUI view, except it's not a view, it's, in our case, a data fetcher. So let's go ahead and set this whole thing up. We add a new environment key to SwiftUI, right? So we make a URL session key that has some default value. If we try to do that, we fatal error. You could also just use URL session shared here, of course. And we add a new environment value property to SwiftUI as well, so that we can access this in our views. We also update our property wrapper. So we make remote data now conform to dynamic property. And we grab the URL session from the environment. Easy as that. Right, so we could update the fetch data function as well to use this URL session instead of URL session shared, and we'd be good. We also implement the update function so that whenever SwiftUI tells us it's about to evaluate the view body, you can update your data now. We go off to the network, fetch our data, assign it to a wrap value, and SwiftUI redraws. Okay, so let's use that environment key. We set up a whole app, post view, environment, URL session is URL session shared, because in our app it's fine to use that one. In our tests we would use a different one. And we build a simple view, right? The code that you've seen before, basically. So that's a lot of talking I just did and a lot of showing you some code. So here's what should be happening. Right, study this for a second while I drink some water. So we have the post view. SwiftUI calls to body. Remote data is asked to update. We fetch our data. We update wrapped value. And we have SwiftUI reevaluate the body to show our new list. Great, we implemented all the moving parts. We run the app. And sadly, this doesn't work. When is anything ever easy with SwiftUI? So what could be wrong here? Looking at that code, I know you're all looking for this. I didn't forget to resume the network call. Right, we know that an update fetch data is called, so that's also not the issue. And we know that wrapped value is updated when we have our data. So what is wrong here? And if you've done work with SwiftUI before, you know that we should somehow tell SwiftUI that new data was fetched. And just updating a regular old property is not going to redraw anything. So we need to make our wrap value state, for example, so that whenever we change this, SwiftUI is like, something that is important marked with state changed, so we need to update the view. Okay, so with that in place, we run the app again, and obviously it still doesn't work because Apple has documentation on dynamic property, but they hid one very important requirement. I fixed the code here. Can anybody see what I changed? Take a second to look at it while I drink more. Wow, who was that? Good eye. Because yes, that is the one change. I changed my remote data from a class to a struct because apparently dynamic property only works if we use a struct. If we make it a class, SwiftUI is like, oh, classes? No. Structs, please. So one more try, and if it doesn't work, I'll walk off stage because obviously it works. So with remote data being a struct, we now can fetch data and we have what we need. So what do we have so far? We have a struct called remote data that confirms the dynamic property. It grabs a URL session from the SwiftUI environment, uses state on a wrapped value to tell SwiftUI something changed, and whenever SwiftUI calls update, we fetch data. So here's what happens. You saw this graph just now, and there's a pretty big issue here because SwiftUI is going to evaluate the body. As it does that, we have our update function called, we fetch data. we update a state property, which will make the body be evaluated. Whenever SwiftUI does that, it calls update. So we keep going in a circle until SwiftUI decides that nothing changed and it won't redraw. So this happens a couple times. Because we do this, right? We fetch data on every call to update. We don't want to do that. So we need to update the property wrapper one more time to make sure that we track whether we are loading data or not, and whether we have fetched data before or not. So we could do something like this. Add a var is loading to the property wrapper, set it to check whether we are loading or not, and also I check whether the wrapped value is empty. Because when it's not empty, I've fetched my data and I'm not interested in doing that again. I set is loading to true. I set is loading to false when we're done. It's all great. We try to compile this, and Xcode starts yelling at us because self is immutable. Self is a struct, so we can't just go around changing properties on it. However, we know from SwiftUI that we could use state here, because state puts our property in a separate storage, and we can now change it whenever we want. Everything is good. We run the app, it compiles, and we get this warning. Modifying state during view update, this will cause undefined behavior. Okay. What can we do about this, right? We can't just make this a non-state property, so we can't make this so that it doesn't trigger a view update, because then we would be making this a class, which was not allowed. So what we should do is we should move the underlying data away from the wrapper, right? So we should make the whole data loading the responsibility of another object that will track whether it's loading stuff or not. It can be a class, and the property wrapper simply becomes like an interface for that object. Okay, so we start doing that. We make a data loader. It's an observable object, which is very important, because now we can use that in our property wrapper as an observed object or state object, just like we would in a view. We have a published property load data, so whenever that changes, the SwiftUI view will change. We keep track of whether we're loading or not. We have an optional URL session and remote data endpoint. And this is very important, because you might be thinking, well, you should pass that to the initializer for the data loader, use it there. But we can't, and I'll show you why in a moment. Then in fetch data if needed, we check whether we have a URL session endpoint, whether we're loading, whether we have loaded before, and we kick off the work just like before, right? We flip is loading as needed, and everything works. And again, because data loader is an observable object, it can tell our property wrapper that it changed, and that will in turn redraw our view, which is great. So we have the data loader, and then we update the view. The view now has a state object data loader, and it creates that without passing it the environment and endpoint. We have the wrapped value, which is now simply a computed property taking whatever the loaded data for our data loader is. And in the update function, we check whether we have already assigned a URL session to the data loader and an endpoint. If not, we do it, and after that we call fetch data if needed. Now, the reason we can't immediately initialize the data loader with our endpoint and with our URL session is that the SwiftUI environment is not set up when this property wrapper is initialized. Right? The environment is set up at the point that SwiftUI evaluates the body, not earlier. So we can't assume that we have access to the URL session when the property wrapper is initialized, which means that in update, we can only reliably read from the environment. Hence why I do this. Okay, so the property wrapper is now pretty tiny. We moved all the data loading logic into the data loader. And here's the final diagram. We have a post view with the body. Whenever that's evaluated, we update. The data loader will fetch data if needed. If there was data loaded, we update the published property, which will make the object will change for data loader emit, which will in turn update the view. A lot of things happening. If we didn't load data, nothing happens. That was quite the adventure. You can imagine that I'm talking about this in like 20 minutes now on stage, as if it's all super obvious and clear. This took me like a week to figure out, like, why does this not work properly? But in the end, I got it to work, and I was able to write my code like this, which I really, really liked, because it feels like this should be in a WWDC slide, basically. All right, so wrapping up the dynamic properties. They allow us to build property wrappers that drive SwiftUI views. They allow your objects to be almost a part of the SwiftUI view hierarchy, which means that you can offload your logic into a separate object and hide that from the view while still having it directly in the view. And it makes it look very similar to what Apple does with state and with all their other property wrappers. this is the best part for me. They can tie into SwiftUI's environment, which means that you get the dependency mechanism that SwiftUI uses right inside of those objects. They can leverage SwiftUI state-related property wrappers because, again, they basically become views themselves, except they're not actually views. And apparently, they should be structs. I found that out the hard way. And the update method is called for every body evaluation. So you want to make sure that you check whether there's actually any work to be done. And I found that typically that means that the property wrapper shouldn't own its state, right? Because it's going to be fetching data from someplace, and you might want to have like a class where you can freely mutate things or freely manipulate things as you need. Bonus, a dynamic property does not have to be a property wrapper. Right? So you could even make your view model, if you want to use that as a state object, a dynamic property, and it will get access to the SwiftUI view environment. So it's actually quite convenient. I just like the property wrapper syntax, but you don't have to use it. So part 2, how do we test this thing? Because we're dealing with a SwiftUI view, we should create a hosting environment in which the view can be set up so that we get access to the SwiftUI environment and all of that stuff. Right? We don't get that if we just make an instance of a struct. We also need a view to test with, right? Because we need some view to have that property wrapper to see if it actually updates. We'll need to somehow know when the view redraws, right? We can't just look at the body property and have to test sit while we hope that it maybe changes. And ideally, we actually also would be able to just read whatever the current wrap value for the property wrapper is. So let's do this step by step. We can create a hosting environment using a bunch of ugly code. We have a function here that will host any SwiftUI view. I promise no generic, I lied, sorry. We create an app, which is just a view controller, a hosting view controller for our SwiftUI view. We add this hosting view controller to the view controller we just made as the app. We add the subview. We set up constraints. I might be wondering, you're not going to put this on screen, are you? This is going to be a unit test. Well, SwiftUI is smart. It knows that if a view's frame is 0 by 0 pixels, nobody will ever see it. So it's like, why set up anything for that view? Right? It has to have like a non-zero sized frame. So that's why you have to do this. Also have to do this, tell it to do a little bit of layout, and then the view would be actually fully set up. So we create a simple view to test. Right? This view does not have a list in its body because we don't really care about whether the list looks good. We just care about the property wrapper because that's what we're trying to test. And then we write a test, right? Just a simple test class, func test remote data is eventually available. Make a view, we add the URL session to the environment we host it. And that's when the problems start. Because we do have a view now, and we applied the environment view modifier to it, which means that we no longer have an instance of sample view, because the environment modifier returns some view, so we threw all of the information we had about the view out the window. We just know that it's anything that would conform to view. We can't make the view first, then access the property wrapper, and then apply the environment object view modifier, because we're dealing with value types, which means that every time we pass them around, mutate them, and all that stuff, we get copies. So we can't do that. So we should add something to the sample view that has reference semantics, which means that we add it to the view. It's going to be an instance of a class, and then we can access that in our test. If that doesn't make a ton of sense, here's kind of what we're looking for. Right? Our unit test needs to create the sample view, and the sample view should contain some reference type that we can use. Whenever the sample view changes, it should tell that reference type that something happened, and then the unit test can observe that reference type, which is a job for combine. So we add a little bit of combine to our view. So we still have that struct with remote data. We have a pass-through subject. That's a combine object. It is a class, which means that it's a reference type, which means that we can just grab it whenever we want. And whenever the view appears, we will send the initial value for our wrapped value for our property wrapper over it. And whenever that feed changes, we will send the new value. So that allows us to kick off work on the property wrapper and basically know when something changed and inspect a new value. So let's look at the full test. Right? So we define a test class, and we create a sample test view in our test function. We make a test expectation because this, of course, should be somewhat asynchronous. We create a sink on the result subject that allows us to receive all the values published by the view. And we initially check that, we only really check that eventually at some point the posts object is no longer empty. It's a bit of a simple test. We don't care that it first is empty and later gets a value. If it's at some point not empty, I'm okay with that. Then we can host our view and set up the environment, and we wait for expectations. And that actually allows us to test this property wrapper, right? It's pretty weird that we have to do this, but with a little bit of creativity and a little bit of messing around, and again, I'm showing you this in a couple of minutes. This took me a very long time to figure out, but it works. And it allows us to test that SwiftUI property wrapper, which is very important if you're integrating this in your apps. So in summary, we can build custom properties or property wrappers for SwiftUI with dynamic property. You can tap into the environment, which opens up a lot of possibilities, right? You don't have to read environment keys that you defined. You can also take things that are already in the SwiftUI environment, which can be really, really powerful. To test a custom property wrapper, you need to set up a view, right? And that view needs to have its view environment and everything set up. So it has to think that it's actually going to be drawn, so that it does all the work that a view needs to do to actually work. And what's really cool with testing this is that a combined subject is a very nice way to get a reference type from the view that you can publish changes on, so that you can observe those changes and know what's happening inside of the property wrapper. And yes, you can make it work as an async sequence. I just chose to not have too many technologies in one talk. Thank you for listening. And if you're interested in seeing the code I just showed for that remote data property wrapper, you can scan this code or go to my GitHub and find SwiftUI property wrapper talk there to kind of see this in action and sort of rewatch all the code, because it's a lot. Thanks.
Thank you, Donny. Let's move on to
the fancy chairs.
I saw a in one of your slides.
Did I?
Yeah, written.
Oh, yeah. I even made them all say it. I wonder how many ums were detected by the machine learning algorithm. Should be about 250.
There are lots of questions by the audience. So I'll start with the last one, which is there any way to handle errors with remote data property wrapper?
Yes, so I currently made this very simple. So remote data creates an array of feed as its wrap value. You could make that a result where the success case is wrap value, and or the post array and the error case is whatever you want it to be. And then you can switch on that in your view. So it would just mean like making the output of the property wrapper result. And you'd be good to go.
Same thing for canceling a request, I guess?
Yeah, so if you would want to do that, you would need to use that underscore prefix first for the property wrapper. That will get you an instance of, or the instance of remote data. And if that has a cancel function, you could just call it. You could also go ahead and say, well, I don't want to expose that functionality per se in that manner. You could use the projected value, for example, for that. So there's multiple ways that you can expose a cancel function.
Another question from the audience. Could you make the observable object conform to dynamic property and solve the optionals?
And solve the which?
The optionals.
More or less. I guess you could do that. Because, like I mentioned, it doesn't have to be a property wrapper, so the observable object itself could be a dynamic property too, and you could read things from the environment that way. So that could. I haven't tried, but I'm like 99% sure it would work.
Actually, it's by Antoine, so I guess you can talk that in private.
I'll find you, Antoine.
So I'm looking for more questions I had. How do you maintain that? So the thing is, when you have lots of property wrappers, it might be hard for people, to understand what property wrappers have been implemented and what are not. And like back in the days of Objective-C, we had those extensions, and at some point, projects had lots of those extensions, and nobody was knowing what extensions were available and what extensions were not.
Yeah. So this, of course, you have to coordinate with your team. Like, which ones are we going to write? And if you do it smartly, your property wrapper is similar to what we ended up with in the talk. they really don't do much, right? They just provide an interface on top of like a data loader or maybe a whole suite of objects, which means that you're not re-implementing logic anyway. But yeah, it's really important that you make sure that with your team you decide which property wrappers you write, communicate which ones you have, and of course make sure that everybody uses that, right? So things like pull request reviews are very helpful there. I also noticed that you can like go overboard, like with extensions, for example. Like you could write tons and tons of extensions, but just write ones that make sense, ones that you actually need.
And maybe a more open question to conclude, one that we ask ourselves every time after WWDC, is Combine dead?
No, no. That's just the short answer. The long answer is, for tasks, right? For getting data, for example, definitely async await is the way to go. It has a clear start and end. It's like it's literally like a task to fetch data. If you're observing state, things become a lot harder. And Tunde actually showed on his slide today that like you have to manage cancellation yourself, where with Combine you have your cancellables and it's all managed for you. And the default is it doesn't work unless you retain a cancelable. The opposite is true if you want to observe state in async await. So if you start iterating over an async for loop, that loop will remain active until you cancel it. So if you start this in a view controller goes off screen, task is still active. And you have to make sure that you retain the task and cancel it and like view that disappear or the D-init. Very error prone. So there's definitely some ergonomic issues, in my opinion, around a complete Combine replacement. Who knows? Maybe Swift 5.8 or 6 or whatever fixes that.
All right.
Great.
Thank you very much.
All right.